Okay, last little bit about voltage. So if you're looking for voltage in a uniform electric field, remember your uniform electric field is what we talked about earlier with the two parallel plates, one positive, one negative, and then the charge on the two plates is the exact same. You come up with this equation for your potential difference called delta V equals ED. Okay, D is again going to be your direction and distance of the electric field. So D is going to be your distance, still measured in meters. This should be distance too. E is going to be your electric field, measured in newtons per coulomb. And then V is your potential, measured in volts still. Okay, so just another equation that you can use to solve for your uniform electric field. Okay, again, uniform electric field has to be what you're going to use. Okay, if you're looking at these potential differences, so the first one we're going to look at is just your battery. If you look on your battery has two sides to it, a positive and a negative side. So your negative terminal is what we call the ground. When you ground something, it's said to have a 0 volts. So we're literally talking about that's where it kind of ends in your circuit. The positive terminal is where you get your potential from. So 12 volts, if you're looking at a 12 volt battery, 3 volts, 120 volts if you're looking at a wall outlet. So the higher, your positive is going to be higher than the negative terminal, so your negative is always 0, and then your positive is whatever voltage it says on the battery. Okay, remember that for all of these, you're looking at your potential difference. So you have your positive side, which would be 12, negative side is 0, so your potential difference or your voltage for a battery is 12 minus 0, which is 12. Okay, that's why it says 12V or 3V, 4V, whatever size battery you're using. Okay, so the thing about a battery is that batteries supply energy. Okay, they don't supply electrons. So when a battery dies, it's not that it's ran out of charge. All of the charge you need to power everything is already there. So when you look at your cell phone chargers, all of the electrons that are needed are already there in the wire. They just need energy to move, which is why you plug them in, because that the wall outlet provides a potential difference, which gives the batteries, or which gives the electrons energy they need to move. So a battery dies when it runs out of energy, not when it runs out of electrons. Batteries don't supply electrons, they just give the electrons the energy they need to move. Okay, so it's just like a big thing, what a battery is. A battery dies when it runs out of energy. Okay, not when it runs out of electrons.